Okay, let's talk about adding and subtracting fractions. Now, adding and subtracting fractions is a whole different ball game from multiplying and dividing. Because multiplying and dividing, it does not matter what you have in your denominator. It's kind of a free-for-all. But adding and subtracting, you have to have a common denominator. Okay, like I always say, the fractions have to be sliced up the same way. It's like you can't combine fourths and thirds because they represent different quantities. Because when you add or subtract, you have to find out the accurate amount which you have, but if they're not divvied up the same way, then you can't add or subtract it and figure out exactly what you have. Okay, so a couple cardinal rules for adding and subtracting fractions. I do this example in all my classes. So let's do a really simple example here. A half plus a half. Now, a half plus a half, that's really easy to figure out, is a whole, right? Or 1. You should be able to do that. Now, when you add or subtract fractions, remember, you only add or subtract the numerators. You do not add or subtract the denominators. Okay, so now if we do this the correct way, we do 1 plus 1 is 2. Don't add the denominators, keep it the same. We get 2 over 2, which is the same thing as 1. Now, if I do this the wrong way, I'm going to write wrong again, just to cover my butt legally here, saying, he told me to do this and blah, 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 Okay, so we look at this one. If I do this the wrong way, if I do a half plus a half, and I add the numerators and denominators, I'm going to get something that doesn't make sense. 1 plus 1 is 2. 2 plus 2 is 4. 2 over 4 simplifies to 1/2. So we think about this logically, a half plus a half equals a half? No. Do not add the denominators, even though some people like to do it because they get the rules for multiplication and division confused with the rules of addition and subtraction. Okay, let's get this example off of here. Oops, erase. Okay, so when you're adding and subtracting fractions, first and foremost, you have to have a common denominator, like mentioned earlier, which, it's pretty simple operations when the denominators are the same. Just do a quick example of each here. Like if I have, for those of you dealing with the construction side, if I had like 1/8 and I need to add 3/8 to that, okay, so we just do 1 plus 3. Here's a really technical explanation of it. Oops, thinking too far ahead there. So you just add the numerators, you do 1 plus 3, which gives me 4, and we get 4 over 8. Okay, and after you do the addition, you ask yourself, is the fraction simplified all the way? And 4 over 8 is not simplified all the way because we can reduce each of these by 4. Divide by 4, divide that by 4. So 4 divided by 4 is 1, 8 divided by 4 is 2. Okay, and it's the same thing for subtraction. Subtraction's the same thing. It's pretty simple when the denominators are the same. It's when the denominators start getting different and they start throwing in mixed numbers that things become a little bit tedious and painful, especially when you're trying to keep track of everything. So when you're subtracting fractions, like if I want to do, I don't know, let's just do like 5/8, stick with 8s here, stick with ruler measurements, 5/8 minus, let's say 3/8. So again, same thing here, you do 5 minus 3 over 8 equals, let's see, so 5 minus 3 is 2. Notice I did not subtract the denominators. 2 over 8, and again, we can reduce these. We can reduce each of these by 2. Divided by 2. So we get 2 divided by 2 is 1, 8 divided by 2 is 4. So we get 1/4. It's 5/8 minus 3/8 is 1/4. Okay, now that's all fine and good when the denominators are the same, but what do we do if they're different? Okay, like I was mentioning earlier, when you have different denominators, well, you have to find a common denominator. Okay, which is kind of an art form in itself. And again, it's kind of like anything with different denominators. Like I always tell everybody, if you're good at your times tables, it's not a hard thing to pick up on. If you're not good at your times tables, you might be fishing around in the dark a little bit trying to find an answer. So like let's say I need to add 2/3 and 3/4. Okay, now I can't add these just as they sit because they do not have a common denominator. Now the common denominator for these ones is, you might have heard it referred to as the LCD, which is an acronym for lowest common denominator. Now what that means is it's the lowest number that both 3 and 4 divide into, not what goes into them. Okay, so the LCD in this case would be 12, because 12 is the lowest number that both 3 and 4 divide into. Okay, so like if you want to prove it off to the side, 12 divided by 4 is 3, and 12 divided by 3, oops, nope. Get my eraser here. Okay, 12 divided by 3 is 4. Now they won't always be the opposite denominator. So when we look at this one, that's the LCD, because that's the lowest number that both of these divide into. Okay, so now here's the part people have trouble understanding in the first couple run-throughs, is when now we have to make these denominators 12. And the way we do this is multiplication. So I think, okay, what do I times 4 by to make it this? Well, 3. Times by 3, and I times the top by 3 as well. Okay, because what you do to the bottom, you have to do the top, because that ensures it's still the same fraction. So that'll give me 9 over 12. 9 twelfths and 3 fourths are the same thing. It's just, instead of this being divvied up into fourths, it's now in twelfths. Okay, let's put the plus sign there. So now we go over here. What do I times 3 by to make it 12? Well, I times 3 by 4. And that's where the 4 is coming from, because that's what it takes to make this denominator 12. And then we do the same thing to the top, times by 4. So we do 4 times 2, which is 8. 4 times 3, which is 12. Then we kind of follow our model we did up here. We just add the numerators. 8 plus 9, that gives me 17. Keep the bottom number the same. Okay, so now we haven't run into this too much. We have an improper fraction. You know, since this is a math for the trades class, we have to write this as a mixed number. So recall the earlier video of changing an improper fraction to a mixed number. So 12 goes into 17 one time. I think that gives me a remainder of 5. 1 and 5 twelfths. Okay, so that's the process in a nutshell. I mean, it'll change a little bit when we do the mixed numbers, but I'm going to do a separate video for that. You know, just kind of small doses. But let's take a look at a subtraction problem, so you can see subtraction too. I mean, the denominator part doesn't change. It's just doing subtraction instead of addition. See if I can find a good example here. Let's do this one. Let's do some ridiculous numbers. If you can do the ridiculous ones, then you can do the easy ones. Let's do 5/6 minus 3/10. Completely ridiculous numbers. You're probably never going to see, other than practice problems you'll do for this class, you'll probably never see 6 as a denominator. You might see 10, you know, dealing with the metric system or things in tenths. Okay, so now we look at this one. I can't subtract these just as they sit because they do not have a common denominator. So what do? I need to find a common denominator. So we look at this one, 6 and 10. Now, when I have different denominators like this one, I always kind of see if the smaller number divides into the bigger number. Let me write LCD over here. So see if 6 goes into 10. 6 doesn't go into 10. Okay. Then I start thinking of things that 6 goes into and cross-check it against 10. You know, 6 goes into 12. 10 doesn't go into 12. 6 goes into, what, 18. 10 doesn't go into that. Okay. Also here, you can use your divisibility rules to make your life easier. So we look at this one. 10 will only go into numbers that end in 0. So with this one, I'm going to find the first number that ends in 0 that 6 goes into, which is 30. Okay, now some people in this one, they say, well, can I use 60? And you can use 60. You're just not getting the lowest part on your lowest common denominator. It doesn't mean you won't get the answer wrong. It just means you have more reduction to do. Okay, so our LCD is 30. So now we think, okay, what do we multiply each of these denominators by to make it this? And then we do the subtraction. So let's start with 6. What do I times 6 by to make it 30? Well, I times that by 5. And then remember, do the same thing to the top. So 5 times 5 is 25. 5 times 6 is 30. And then what do I think? Okay, what do I times 10 by to make it 30? Well, I times that by 3. I do the same thing to the top. Let's see. So 3 times 3 is 9. 10 times 3 is 30. Okay, so now we just go ahead and subtract these. Let's see, 9 minus 25, what does that give me? 16 over 30. and we ask ourselves, okay, is this reduced all the way? And again, oops, put the equal sign there. And again, you should think, okay, these aren't reduced because these are both even numbers, so we know 2 can go into these. So let's go ahead and reduce these. So you can reduce this by 2. And again, with this, you don't have to write the division. I'm just kind of showing it for the benefit of the video. So in case you're wondering where this 8's coming from or where the 15 comes from. Okay, so then we get 8/15, and we know that's reduced all the way because the only things that go into 8 are 1, 2, 4, and 8, and neither of those will go into 15. Okay, so that's how you add or subtract fractions. Now in the next video, I'm going to show you how to add or subtract mixed numbers because kind of some funky things can happen with that, and there's multiple ways you can do it. And I'll show you multiple points of attack for that.